Welcome, everybody. We're just having everyone sign in, and thanks for participating in our breakout. Just another minute or two here. Hang on just another sec, everyone. We're just getting our panelists arranged, so get comfortable. Okay, we're going to get started here, and welcome everyone to our breakout session 2.1. This is Building Energy Efficiency and Improving Affordability. I'm Senator Henry Stern. Pleasure to be with you all here at the 9th Annual EPIC Symposium deep dive here on buildings and efficiency. This topic is very important to me. I represent a part of Los Angeles that's technically had the hottest days on record. We hit 121 in Canoga Park and Woodland Hills in the areas I represent. So whether it's extreme heat or other kinds of resilience needs, this panel's urgent. And we have some of the nation's leading experts in the science behind buildings and energy. We're going to get into some exciting topics here today. I myself have been working on bolstering the CEC's ability to go big when it comes to not just building decarbonization, but to quote the late, great Art Rosenfeld, into the negawatts. As we electrify our building sector, we know that the pressure on the grid of a clunky and inefficient system is going to be a load liability deep into the future. So unless we are looking at our existing building stock in an aggressive way, and as UBS just put it a few days ago in their report, a retrofit revolution, and looking at the inherent carbon savings as well as energy savings we get from retrofits, and we get from things like prefabrication, that's 75% less carbon intensive to go fix a building than it is to build a new one. And we know there's lots of new exciting tech on the new side, but I'm hoping today we also get into how to deal with the building stock we got and to do more with it, and therefore decrease load, increase affordability, and hopefully make people's existing lives markedly better. That's, I think, if we're going to be able to advance a climate agenda that's rigorous and real, people are going to have to realize that just makes their life easier to have good technology. Just like they want to upgrade their phone or want a car that works, they're going to want a building that works too, and they already do. So I want to introduce our first guest, and we're going to actually have everyone join in. We're going to do about 2 minutes at the outset of just some introductions and tell you a little bit about their work, and then we'll get into a discussion and hopefully get some Q&A going in the chat as well. So hopefully be iterative. And yeah, go ahead and add everybody. We don't need to drum roll too much, although we'll give Andy the official drum roll here. So Mr. Brooks, you're first out the gates, Senior Director for Western Region at the Association for Energy Affordability. So welcome, Andy, as well as Aaron Tam. We've got here as a researcher at the Energy Policy Research Institute, and Curtis Harrington, who's here as a Senior Research Engineer at the Western Cooling Efficiency Center at UC Davis, as well as Martha Campbell with RMI, or the Rocky Mountain Institute, who's the Principal of Carbon-Free Buildings. So welcome to you all today. I'll kick it over to Andy out the gates, and we're going to get into it in a bit, but we're very interested, especially in your work on water heating. But I know you do much more than that. So welcome to the program.
Thank you, Senator Stern. Privileged to share a stage with you, virtual stage with you. So yeah, hi everybody. I'm Andy Brooks, Senior Director at AEA, and we are a nonprofit technical services and training organization focused on bringing the benefits of clean energy and energy efficiency to underserved and disadvantaged communities. And we do that through a variety of ways. I don't know if we have the slide deck up. Is that I don't see it.
We'll go to slide. Kick it off. Just give us 30 seconds, and then we'll come around to slides. I'll come right back.
Oh, gotcha. Okay. Yeah. So yeah, we focus primarily on multifamily program implementation. So we implement a variety of different low-income multifamily programs throughout the state for state and local government agencies, utilities, and CCAs. And I'll talk a little bit more about that when we get into the slides, I guess.
Okay, great. Let's go next to Curtis Harrington. I see you up there, Davis. We got different rooftops on our virtual backgrounds, but can you just tell us a little bit about your work over there at Davis at the Cooling Efficiency Center?
Sure. So again, thanks again for having us, Senator Stern, and appreciate having the opportunity to join the panel. I'm an engineering manager at the UC Davis Western Cooling Efficiency Center, where we conduct research related to building energy efficiency, kind of broadly. We have a number of projects with the California Energy Commission and the California utilities, as well as some federal projects as well. But essentially, we do a wide range of technology demonstrations in the field of emerging technologies. We have a laboratory where we can test equipment in our environmental chamber. We have expertise in building energy modeling and support building codes and standards enhancement for the state. And we also have a market transformation team that looks specifically at market barriers for emerging technologies, which is a huge component of the EPIC program. So yeah, happy to be with you all.
Thanks for coming. I'm going to go over to Martha Campbell, and I know we're going to get into prefabrication, but and some of the sort of technical issues here, but I mentioned Art Rosenfeld at the outset. Amory Lovins also, in terms of, I think there's a healthy debate in terms of who the godfather of the efficiency gospel is, and RMI is certainly at the sort of original DNA for that. So it's exciting to have you all here today.
Thank you. It's an honor to be here with you all, and I'm really excited for our conversation. So I'm Martha Campbell. I'm a principal on our carbon-free buildings team. For those that aren't familiar with RMI, we're Think and Do Tank. We've been around for about 40 years, co-founded by Amory and Hunter Lovins, and very much focused on decarbonizing all the different end uses of energy in our economy. We had our origins sort of with a North Star of geopolitical security. I think that still remains relevant today. But we obviously now are all eyes on trying to hit a 1.5 degree future here in the I guess the decisive decade, as we call it. So like I said, we focus on the 4 end uses of energy: buildings, transportation, the power sector, and industrials. We are now focused globally on market transformation, and we use a variety of different levers to try and like I said, decarbonize our global economy. So I'll stop there.
You've set very high expectations. We're expecting you to solve world peace then on this panel.
Right.
To make good on that mission. But we're chipping away at it here. We really are, megawatt at a time. Last but not least, Aaron Tam, welcome to the breakout session here, sir. We know you're a researcher at EPRI. And we're going to talk a little bit about things like heat exchangers and refrigerants. But welcome, and maybe just a quick kickoff on what EPRI does and what you do there.
Yeah, thank you very much. Sorry about my connection issues earlier, but yeah, I'm a research engineer at EPRI, which is the Electric Power Research Institute. We're an independent nonprofit organization, and our mission is to advance, safe, reliable, affordable, and clean energy for the society. We collaborate a lot with our utility membership, helping them, understand the different technologies that are coming down the pipeline and how they can, build programs around it. And within EPRI, I'm part of the Grid Edge Customer Technologies program, where we focus on the end-use devices. So, thermal system is a huge part of that, and we understand heat pump technologies have a key role to play as we continue to electrify and decarbonize our, the way we interact with energy. So, happy to be here, and yeah, thank you for giving us the opportunity to share our work.
Yeah, cool. Well, let's start the sharing. Let's get into it. We'll go with back to Andy, and just as our sort of central thesis and theme here, hoping as you go through your presentation, really role of affordability here as we innovate, and how you're really you talked about sort of equity driven work you're doing at the association, but cost effectiveness and sort of where you see that sort of aligning with the tech that you've been researching would help. And for all the panelists, really, we want to be both the low cost and the low carbon solution here. So, but take it away, maybe David or Eddie, any of our administrators. Eddie's right on it. Okay, go at it. Go for it, Andy.
All right, thanks. Yeah, you can go to the next slide. I mentioned that a big part of what we do is program implementation. And our role in those programs is in addition to the general administration, is to provide all of the kind of technical assistance to owners, property owners that are needed to get the project through to completion. So that's everything from the site assessment, energy modeling, developing the scope of work, cost estimating, getting contractors on board, construction oversight, pretty much everything or anything that is needed. But we're also engaged in a variety of other things that we show there, policy work, and we do a lot of training and education. And then, of course, we're also very engaged in R&D work through the EPIC program. But the main reason we do that work is so that we can help move kind of new technologies that have been tested in the kind of controlled environment of a research project into our programs, which then in turn helps kind of prime the market, the open market, to start adopting those technologies. So you can go to the next slide. I'll talk a little bit about this specific project, which is an example of that. So for this project, we're working very closely with two manufacturers of new carbon dioxide refrigerant-based heat pump water heaters that are specifically designed for central system applications, which for us probably over 50% of our affordable multifamily projects that we work on have central systems. So we're demonstrating these systems in retrofit applications at 5 different affordable multifamily properties throughout California. And they are obviously heavily instrumented, and we're tracking performance and providing recommendations to the manufacturers on how they can improve the products and kind of make them more amenable to the types of multifamily projects that we typically work on. And then ultimately developing design guides for the design and installation community, and get into kind of more of the challenges and touch on some of the affordability aspects that you asked about when we get into the Q&A as well. But that's kind of a high level summary of that specific EPIC project that I'll be talking about.
Excellent, thank you. Do we want to keep it rolling here? And I mean, I certainly have follow-up questions for you, and those of you who are participating as panelists, as participants, attendees here, do feel free to use your Q&A as we go along if you're listening to these topics and things you want to drill down on. But we'll keep rolling through the high-level presentations, and then we'll come back around and dig into a discussion here. So, Curtis, do you mind? Are you ready for us to
yeah, let's
kick off?
I'm ready. There we go. All right. So, on the theme of affordability, we have a lot of projects here for the California Energy Commission and the utilities, but I'm going to highlight one particular project that we are doing for the EPIC program on affordable low GWP heat pumps. GWP is global warming potential. There is a new ruling by the California Air Resources Board that is going to take in effect soon that requires the global warming potential of refrigerants to be reduced. Obviously, that's going to be a big shift in the equipment that we're using in our buildings. So this is kind of a project kind of testing the waters with some of these refrigerants, or at least one particular one in this case. So this project's taking a two-pronged approach to addressing this challenge. For the near-term solution, we're working with Rheem manufacturers that has developed a new heat pump technology that incorporates a low GWP refrigerant. It also has a novel compressor drive technology that allows the system to operate at variable speed with lower cost components. So that's really where you get to the affordability aspect. It's not just on the first cost of the equipment because of the affordable components, but also the reoccurring savings from the more efficient variable speed operation. So this technology presents an easier path to market just because it kind of resembles a more typical HVAC system that you would see in a home. It's a typical like split packaged unit or split system unit. For the medium-term path, we're developing new heat exchanger technology to improve the performance of air-to-water heat pumps. We expect that this refrigerant transition will continue and that this phase that we're in right now is going to be fairly short. And so as we go to ultra-low GWP refrigerants that are either highly toxic or flammable, think of propane or ammonia, things that you wouldn't want in your home. We see a role for air-to-water heat pumps where you can maintain that refrigerant outside. And then you use a secondary fluid loop, in this case, water and glycol, to bring that heating and cooling into the building. Inside the home, it's very typical to the old style system. You have an air handler. In this case, it would be water coil, hydronic coil that you would use. And so the microchannel polymer heat exchanger that we're developing is for that particular component, that hydronic air handler in the space. We're showing 20 to 30% better effectiveness than standard kind of coils that are used today in hydronic air handlers. So this will improve the performance of air-to-water heat pumps and potentially be a pathway to ultra-low GWP refrigerants moving forward.
A very exciting teaser. I hope our participants are getting also excited because I'm eager for follow-up, but we're going to try to stay disciplined here and keep going. But I'm taking notes as we go. I have Aaron here on my list next. If you're up for it, Aaron, jumping in and giving a quick overview.
Yes, thank you. So yeah, one project I would highlight that I'm currently leading, funded through the EPIC program, is the development of a near zero global warming potential heat pump system. I think Curtis touched on some of these points earlier. As we choose lower and lower GWP refrigerants, you tend to run into issues like toxicity or flammability. So in this case, we're investigating the potential of using ammonia for space conditioning. Ammonia as a refrigerant is fairly well understood. It's one of the first, working fluids that we've ever, used in the industry. However, it is, toxic and it can't be circulated into your indoor environment. So in this case, we're looking into the potential of using CO2 as the distribution fluid instead of your typical hydronic system. And the reason why is because of the higher heat capacity of CO2, you can actually decrease the piping diameter. So that translates to lower installation costs because instead of steel pipes, you can potentially use some copper iron alloys. So we think that has some potential also in efficiency as well. So the key challenge so far has been trying to make this work in heating mode, because in heating, your carbon dioxide is going to be in a supercritical state. And one of the first findings that we've had so far in small scale lab testing is that we can actually circulate that supercritical fluid with our liquid CO2 pump instead of having a CO2 compressor, which further decreases the upfront cost of the system. So our initial kind of market is looking at small commercial applications, but potentially scaling it up or down once we work out all the kinks in the prototype.
Okay, excellent. And what we'll do when we go back through Q&A too, we'll pull these slides back up so participants can follow along. Martha, you want to round us out here and talk a little bit about prefab, pre-integrated mechanical systems, get into the envelope issue maybe a little bit?
Yeah, so hopefully these two pictures are worth, what is it, 2,000 words? So I guess kind of zooming out a little bit, we've been very fortunate to receive funding from the California Energy Commission to look at kind of two things. So one is the emerging technologies that we can combine to create a more standardized retrofit package for multifamily housing, specifically focusing on multifamily affordable housing and DACs. But then once we have a standardized package, how do we scale that across the state, or a set of standardized packages? And so the images on this slide are of one of our demonstration projects in the Central Valley. It's called Veracruz. It's farm worker housing. And you'll see some elements of the different technologies that we tested on this complex. But the one that's hopefully jumping out at you on the left are these what are called metal insulated roof panels. And they're a prefab product that you can just kind of come on. You take the the existing roofing material off, and the insulation is directly embedded on the panel that you install on the roof. And so we were really excited about trying out that technology. I can go into more of the specifics maybe during the conversation about the different packages that we developed, but we were sort of testing out sort of a business as usual electrification package versus some new HVAC systems. We replaced all of the windows with double pane windows. We tried to provide some degree of ventilation through the bathroom and the kitchen, ongoing continuous ventilation, as well as a humidistat in the bathroom for when it starts to get more humid in there when you're taking a shower. We, of course, obviously replaced all the lights. We did LED lighting across the complex. And then we tested a few different hot water systems as well. And again, all with the intention of trying to kind of see how easy it is to install these technologies, how effective they are. But the goal is, again, to then basically determine a set of standardized packages that we can apply to many similar complexes like this across the state. And we're working with a variety of partners, including co-panelists, AEA, and UC Davis here. So we're excited to dive in more during the course of our conversation.
Okay, very cool. Thank you, Martha. And by the way, thanks everyone participating here. I'm looking through the Q&A. Got some questions already accumulating versus central heating pumps and distributed, and how flexible load could work from Craig. People are asking about Cool Expert technology, air to water heat pumps from Adam, as well as sort of the standardization of some of the packages, particularly in DACs and LMI communities, but also for single family homes as well. And then question about Veracruz follow-up too. So we'll come back to you, Martha, on that, on where generation fits into that, and how you think about the expense of installation versus looking at parking canopies and how that fits into your standardization model. But before we do that, that's the little teaser. Let me just touch a couple of my big ticket questions. Andy, if you don't mind, and you guys can come back on for a sec if you want to just get away from the PowerPoints for a quick sec, but we can also go back if you want to cross-reference. I had two top line ones for you. Just unexpected discoveries from your research, especially with these older multifamily buildings that you're seeing out there. I had a note in here that you discovered some things on recirculation losses, and maybe some common assumptions that we should revisit about, is there really a built-in need to upsize electrical services, or can a lot of this work be done on electrifying water heating without sort of those wholesale big panel circuitry upgrades that are going to deter a lot of that investment?
Yeah, sure. I'll start with the kind of challenges of working in older buildings that you talked about first, and that recirculation system. So, I mean, with any retrofit project, particularly in older buildings, some of the kind of challenges that we face in every project is just space constraint related issues, where to site equipment, And then, like you mentioned, electrical capacity issues. But one of the biggest challenges we deal with, specifically on central water heating system retrofits, is the existing distribution system and the recirculation system in particular. And in most cases, the existing piping is extremely old, and more importantly, very unbalanced. So that imbalance of the distribution actually leads to huge amounts of energy waste. So in one of the projects, the building's recirc system, that imbalance accounted for 60% of the domestic hot water energy consumption. So you can kind of like forget about the heat pump retrofit, just addressing the recirc system imbalance alone was a huge savings opportunity. But then also, in order to meet that existing load, which included the recirc losses, we would have needed a 3 heat pump system and a larger swing tank, which we wouldn't have been able to make pencil for the owner. So we ended up having to do that whole project in 2 phases, where the first phase, we just addressed the recirc losses, which involved installing thermostatic balancing valves throughout the building, and then insulating all the pipes. And then phase 2 was the heat pump install. But with diagnosing and fixing those imbalances in older buildings in particular is incredibly difficult. In that building, we had our team was like crawling through ductwork to find all the returns. We even had to have a specialty contractor come in with a harness rig that allowed it to rappel down a light shaft in the middle of the building in order to install balancing valves in places that there was no other way to get to than that. So that's kind of an extreme, the far end of the research challenges, but literally every project that we go into has some version of that we have to address, that poses kind of like an upfront cost challenge and logistical challenge. And then just very briefly, the other kind of big challenge that we've experienced on these projects in particular is contractor skill and knowledge. These are still really new systems, and if you don't have to pull the slides up again, but if you look at those slides, you'll see what looks like kind of a pretty complex land of pipes, and it's very different than what our typical multifamily existing boiler storage tank, that's like as complex as it gets. And now we're asking them to put in heat exchangers and multiple circulators and lots of and a large control panel that requires specialty knowledge in how to wire it. So getting contractors comfortable and familiar with that is definitely a huge challenge. And then you also mentioned the electrical service issue, which actually, that's one of the nice things about central domestic hot water heat pump retrofits is they've kind of become the low-hanging fruit, because in many cases, you actually doesn't really require an electrical service upgrade. We did have to do a panel upgrade at the first site, but there was an existing panel in the boiler room and there was enough electrical capacity. So a panel upgrade in that kind of situation is actually pretty simple. And actually, in the older a building is, the more likely it is that it probably has already gotten some sort of electrical infrastructure upgrade over the years, generally as part of like the every 10-year tax credit rehab resyndication process. So that first project that I mentioned earlier was built in the 1920s, but all its electrical infrastructure has been upgraded to, so now it's, I think in the 80s was when it was last upgraded. So larger buildings, I would say, tend to be less likely that we have to do a major service upgrade to. Smaller buildings, like scattered sites that have a bunch of four unit properties on it, where the house meter is really just serving like a couple of outdoor exterior lights, that's where it's more likely that we have to increase the service capacity there to accommodate a heat pump.
So it's a little daunting, some of the observations in that, on the recirculation side, in spite of all the exciting technology innovation and efficiencies we're seeing in the new central water heating technology, that initial recirculation barrier is going to be, do you have a sense of how, you said there's always a little bit in everything pretty much if it's older. Given the building stock we've got, say in California, how gargantuan is that task of a high value contractor for every light shaft out there, and people willing to sort of get into the, those aren't simple jobs. So like, do you have a sense of the scope of that work?
I would say that probably at least 50% of the projects that we work on that have central systems have some sort of balancing issue to address. And it's not something that people historically have been addressing. So there isn't like, it's not part of your typical plumber's repertoire to go out and identify the imbalance and then be able to diagnose how to fix it. It's pretty complicated. So that is part of like what is going to have to become, part of a mass training effort is, these projects are relatively, I think we're going to get to a point where doing a central heat pump water heater retrofit is pretty straightforward, but that part is always going to be quite kind of specialized, and so it'll have to be part of like the mass training effort to get contractors up to speed on how
So
to
mass training, yes, but also on the regulatory side, like how do you see, say, the state energy agencies or the Public Utilities Commission in particular? I mean, do we have a role in sort of pulling some of these? I would assume that they are ultimately cost effective, what the payback period, but how to accelerate that payback period. And do you see a role for, say, the CECs or the CPUCs out there?
Well, I mean, I think in the context, in the roles that they play in incentive programs, yes. I think the cost of preparing the building to be electrified has to be included in the incentive structure of a program. So if they're funding programs to go out and install heat pumps, and their costs or their incentives are designed to cover the labor and materials associated with just installing, connecting the pipe and moving on, that's not enough, because we all know that everyone's aware now of the electrical infrastructure costs that are associated with it, and we know that those have to be incentivized in order to make these projects happen. Same thing goes for this kind of specific nuance of, balancing the resource system. That has to be factored into the cost, essentially.
Right. And so even as we sort of set out, say the governor set out his 6 million climate ready homes and climate smart homes, and we've set some heat pump targets. And but when we talk about sort of comparing the budget allocation to the targets, to say the $1 billion we put towards equitable building decarb in last year's budget, and to just multiply that by 6 million heat pumps is actually not accurate math. That to fully understand what that deployment looks like, you've got to sort of embed that prep cost or whatever it may be. So
yeah,
we'll be looking to you for more on that, because I think it's going to help us right size our ambition and potentially have to upsize the budget on that front.
Yeah, the budget has to be factored with ranges. Definitely has to be factored with ranges, because one thing that everybody knows at this point is that the cost of electrification is intensely variable from project to project, because projects that require significant electrical service upgrades can be 5 to 6 times the cost of ones that don't. And all those types of nuances just means that every project has a pretty, the range that you're using on a per project basis has to be pretty wide.
Yep. And this is a follow-up that I'm going to just ask of everyone as we go through. I thought Cammie Peterson asked a nice question there, which is, did everyone get to stay put while this was going on? I would imagine not in your case. Did the building have to be
Yeah, no, absolutely, they stayed put. Yeah,
right.
I mean, specifically on what we're talking about with the central heat pump water heating system, there's no need to impact tenants at all.
Yep.
Of course, water heating is a critical service that cannot go down at all. So that's the big risk, especially when we're dealing with low-income tenants. The last thing we want to do is compromise the delivery of hot water. So we do have to make sure that while we're doing the switch over from the boiler to the heat pump, that there's a temporary system in there that provides hot water in the interim, which is usually pretty short, but no one has to be moved or anything like that.
But getting the landlords confident enough and the building owners confident enough that they're going to be able to fulfill their warranty of habitability there and not have some liability on their hands for making the switch will be probably an important issue to look at and get some surety or some way to shore that up. Yeah. So let's go deeper. We'll come back to Andy, but I want to go. Let's get into refrigerants here for a second. We were talking about air handlers and some of the variable speeds and more sort of efficient technology that Curtis, you were looking at. And then we know that also Aaron had some interesting research on the distribution fluids and sort of how to deal with these sort of traditional toxics, but turning them into assets potentially, especially on the CO2 side. Maybe Curtis, can you just jump in for a second and the challenge on the old to new switch and whether are there that heat exchanger issue seems central, but also in the medium term, the variable speed drives and the sort of lower O&M over time on those systems. But up front, how serious are the barriers looking right now, and what do you sort of see as the main impediments?
Yeah, so the heat pumps we're installing right now, these near-term solutions are using refrigerants that we're all going to be probably using within a year's time in new installations. These refrigerants are, people are debating on what low GWP is, and I think it's a moving target right now. The CARB requirement is under 750 equivalent CO2, and I think that's going to quickly drop below. But transitioning to below 750 is actually not that challenging. There are fluids that are very similar to the current refrigerant. So manufacturers are able to, with minor modifications of existing equipment, incorporate these refrigerants. Now, they are mildly flammable, which is not very flammable like propane, but they do tend to affect building codes and mechanical codes. And so that's where a lot of the work has been, is how to address these refrigerants moving forward. And manufacturers have addressed it by, installing leak detection sensors. So a lot of the onus on this development has been on the manufacturers, I would say. And just in my limited experience of installing these with contractors in California, the actual installation looks no different to them than the old equipment. So I think this initial transition, and I do expect we'll have another one, is actually going to be fairly easy on the contractors, but manufacturers are going to have to, they've already kind of moved their production to looking at these new refrigerants, and I think they've had to do most of the development. But the contractors seem fairly comfortable with these newer refrigerants.
What systems are there out there for mitigating those sort of low flammability, but sort of low risk, but more risk than none issues? I know that there's secondary loop systems that are emerging and other things. Is this, do you see this as a sort of impediment to manufacturers wanting to experiment with this work and incurring any additional liability? Or does that, where does that fall, and how do we sort of make this risk proof so that everyone sort of zealously, pursues this without any sort of downside?
I think manufacturers are chasing the market, and if California makes a change to codes and standards, they are going to make a shift to address it so they can play in that market. The refrigerants these refrigerants I'm talking about, they're considered mildly flammable. They're used all across Europe and Japan and Asia. So there's
not ammonia in this case, Curtis.
So I am not talking about ammonia, and maybe Aaron can touch on that. I am working with 454B, but it's similar to R32. So those are the kind of the two fluids that are at the top of kind of taking over for R410A, at least in my view, for residential systems. Now Aaron can talk about some of the larger systems and CO2 based and other refrigerants. And
that's more on the commercial front. Those are the larger systems, but the small stuff that most apartment or homeowners would see.
And then that's why I was looking at the medium-term solution, because I do anticipate there being propane refrigerants and ammonia in residential, and how do we do that while mitigating risk? And that's why we're looking at air-to-water heat pumps as one potential avenue to mitigate those concerns.
Understood.
Yeah.
Aaron, thoughts on I know you were working with slightly different fluids, but you nonetheless, some of the sort of distribution systems that you had sort of looked at, the loop systems, any thoughts on that in the context of your work or in the broader discussion? It's okay, by the way, if you ended up on phone line here, don't sweat it.
Yeah, I just want to make sure that you guys can still hear me.
We can. We got you.
Okay. Yeah, so on this topic of flammable refrigerants and secondary loop system, so obviously manufacturers are reacting to refrigerant regulations. What we are seeing is there are limits on how much charge you can put in to a system, so how much refrigerant a system can contain. In the US right now, for propane, that's quite low limit at about 150 grams. But we're seeing international standard bodies starting to raise those limits, and manufacturers are already reacting to that. We're seeing much more propane-based, heat pump water heaters and small residential scale heat pumps showing up in, China and India, and to some extent Europe as well. So really what we're trying to do is help our utility members understand, well, what's the difference? Usually from capacity or efficiency standpoint, it won't change a whole lot, but the main concern obviously is safety, which is why we bring in that secondary loop so you can isolate all that flammable refrigerant in your primary equipment, which can be outdoors. That also makes it a lot easier to, from an installation perspective, because everything can be factory assembled, pre-charged and sealed, and just delivered on site, meaning your contractors, right, don't really have to deal with that refrigerant piping. So that's kind of the landscape for flammable refrigerants. This move towards more environmentally friendly working fluids is pretty inevitable, I think. So it's more like getting all the pieces ready for that transition when it comes. And just one other thing on the secondary loop part is every time you introduce like an additional step in that heat transfer process, you're inevitably going to have some losses along the way. Like no, heat transfer process can be 100%, efficient. So that's why we're looking into alternatives to, your typical hydronic system, like using CO2 as a distribution fluid, where you can start making some more efficiency gains and potentially offset the, reduce, right, your upfront costs for these systems.
Right, that makes sense. And that's actually, I was going to ask Martha that the same sort of question about the relationship between efficiency and decarbonization, and how you sort of look at that tension, I guess, if you will, or is there one? And how would you evaluate that? Because I know that's for a lot of us out there who want to push aggressively on building decarb, we're sort of met with, some of these challenges on the cost side up front. And so, how do you wrestle with that?
I mean, I think it boils down to, RMI's philosophy, right, has been you always start with efficiency and you try and find these systems where they're stacking benefits, right? And then you size your system. And I would say, we still have that philosophy, but I do think it's a function of who is bearing the cost, right, of decarbonization. So in a building, if you're going to really focus on the efficiency of the building, let's just keep it to residential for now, where for the most part, we know that we can sort of reduce some of those thermal loads by improving the envelope. The burden of cost is on the building owner. But because some folks just say, we don't need to waste a bunch of time on efficiency. The grid's going to be 100% renewable. Let's just electrify these things.
Right.
But then, right, the burden of the cost, right, is at the central system. And then we have to update all these distribution systems. And people say, oh, but we're going to electrify
build more power plants,
or build more power plants, or we're going to, transportation is going to be electrified. So we're going to have to make these distribution system improvements anyway. But I think there's still a lot left to be figured out, right? We have this giant duck curve in the middle of the day. We have all these electric vehicles that are going to be coming online. Like, shouldn't we have an efficient way of dumping all that? Instead of doing curtailment, let's dump all that energy into those cars when we can use those batteries later, right? So I don't know exactly how all of this is going to play out. I'm leaving that to the master power sector planners, but I guess what I'm trying to say is RMI has recently been doing a study where we're trying to determine what is the value to the grid of envelope improvements. And there are definitely values to the grid, right? Where you don't have to make those distribution system improvements. And you don't have to have another peaker plan, or et cetera, et cetera. And so I think, efficiency used to be cheap. It's getting more expensive because we've skimmed all the cream off the top. And so from my perspective, the reason that we've been focusing on trying to standardize the package is when you have standardization and you have repeatability, you can start to do things at scale. You can get those economies of scale. And so we're not trying to figure out how to electrify or decarbonize every single building. We're trying to look at very common typologies to find that package. And then to Andy's point, train an ecosystem and a network of contractors and service providers that know how to do these types of projects and can do it in a rinse and repeat way. And then we build the pipeline to give to them so that they can say, look, we know we're going to have an ongoing pipeline of business. We know we're getting smarter. We're going up the learning curve. And then we're going to see that price come down. And as we see that price come down, efficiency can once again become, a more cost-effective way to decarbonize. And then the last thing I'll say is, it's not just about efficiency. It's about a host of other benefits that these types of buildings provide. We're, to your point earlier, we're getting into a future where it's going to get hotter and hotter. Having a beefier or better insulated building is going to help mitigate those extreme heat event impacts on people who are, at the present moment, the most likely to suffer the consequences of being in a crappy, uninsulated building. It's poorer communities, disadvantaged communities.
Yeah.
So
That's a technical term, right?
Disadvantaged communities?
No. Beefier and crappier.
Yeah.
I love it. It actually makes sense to me as like someone with not very beefy and pretty like poor, no insulation in a San Fernando Valley home with a 6-month-old and a 2-year-old. And, you've got to just crank that HVAC to get through those days where you're just, it's flying out the roof and your bill, hit $1,000 a month bill in DWP country.
Right.
Scary, right? And that's for somebody, I'm an environmental lawyer, I'm a senator, like I make a just fine salary, but like just to know that's happening live and to feel so, even for me sitting here as, chair of the Joint Climate Committee and the person who's supposed to know about this stuff, it's still not, the HVAC contractor won't come tell you about your insulation needs, right? They're going to go do what they do, plug their box in, whatever they like, and they're going to do it. And so it's tough out there. It's a very disaggregated and sort of not standardized world of heating and cooling that I think you're smart to focus on that scalability. What are those big ticket items then that emerge to you as sort of the things that are no regrets that we just should be doing anyways? You're talking a little bit about envelope. Do you have a sense of sneak preview or a sense of that sort of grid savings? Is that report not done yet to sort of quantify what we might be able to get from that kind of envelope work?
Yeah, I will be very honest. Efficiency alone is not going to pay for things at their current costs. And some of these technologies are, like I said, they are bleeding edge technologies, like these retrofit wall panels that we've been working on with one manufacturer. This is totally new for this manufacturer. And, it's been painful for them as well to basically get up their own learning curve, figure out how to coordinate their own team to develop these types of products. So I'm not trying to be negative.
Realistic.
We need to continue to invest in this type of R&D, continue to create a pipeline so that it sends a market signal to manufacturers to get serious about their product development. And that, because I just wanted to finish, like these other benefits, extreme heat, there's fires, right? If you have a metal roof, maybe your roof is less flammable. We also know that closing off. So what we did on that building where we put that metal insulated panel roof is we sealed the gables off and we air sealed the interiors, and that unit actually had the temperature differential in the attic is like 15 degrees during the day now, whereas for an attic that doesn't have those metal insulated panels, it's like a 70-degree temperature differential in the summer. It's massive. So again, the heat, but then also the fire risk, right? And so how are all of these different co-benefits, how do we monetize them, right? We're looking at the insurance sector basically trying to pull out of anywhere that has climate risk, which is going to be the whole world. So, what are we going to do about this? So these are the types of things that we need to start figuring out how to monetize, because they do have real value. They have value in people's equity. You won't be able to get a mortgage if you can't get insurance, So I think there's still a lot of work to be done there. But I guess in terms of the technologies, in my mind, that I think we need to continue to double down on. I mean, obviously the work that Andy and Aaron and Curtis are doing is profoundly important. But on the envelope side, I do see it as air sealing, technologies like air barrier and AeroSeal. We tested those. I think we need to see like more efficient ways to install windows, because you can buy a really great window, and if it gets installed incorrectly, you wasted your money, because the double pane doesn't matter if it's leaking around what was installed. So people know how to do that. And then I think ventilation and energy recovery ventilation systems is going to be critical, where we have smoky days for months on end in California. I mean, so anyway, you got me on my soapbox, but I'll hand it back over to you.
No, it's my soap. My wife listens to me just for the last 4 months through summer in San Fernando Valley in a very similar vein, less articulately, more so just a random anger at, our bill, the heat, the grid. Meanwhile, we've got also Aliso Canyon in our backyard, and we've got Ormond, the peaker plant, that has a big pipe from Aliso right out to the last clunky gas peaker in that whole part of North LA, in a disadvantaged community right in the middle of Oxnard. The state's firing that up again. We just took out a $1 billion contract for 5 of the clunkiest old peakers in the entire LA basin to deal with this. And so again, okay, there's cost associated with some of these improvements, but what's that avoided cost? Like, how do we not have to enter that next $1 billion contract for those gas peakers if we can shave that peak down? And really trying to find, those creative opportunities. I mean, we're even in my background here. This is Wholesome does this work with Malarkey. This is like this smog reducing tiles that they're starting to deploy with Climate Resolve and some of the folks who are doing multifamily affordable. But you can even get air benefits, where the air districts, everyone from air districts and those who are trying to reduce smog forming pollutants to the insurance industry. And that's not just fire insurance, that's health, right? Because if you look at the #1 cause of premature birth and maternal issues, it's heat. And so how to look at some of those sectors like health, insurance, places that don't always see themselves as connected to the grid, but starting to bring those value chains to bear and maybe take down some of the cost in those ways. Right now, landlords aren't required to guarantee that your apartment's cool, right? That's not under California law. There's no warranty of habitability for cooling. It is for heat, but we don't have such a problem with the freeze here in LA. It's much more about heat. So those are big outstanding issues we've got. We've got five more minutes here. But I mean, anything back from anything burning for you all from the other panelists? I was going to go through a little bit of the Q&A here. If you guys want to.
One quick comment.
Yeah, jump in, please.
The efficiency versus decarbonization.
Yeah, take that one on. I'd love that.
Because we work mostly in affordable housing, and we're dealing with low-income tenants who have really high energy burdens. So if we just go running around just installing heat pumps and just electrifying them, their utility bills are going to go up. We're going to make that energy burden worse. And so right now we can't do that without also coupling it with efficiency. As much efficiency as we can eke out, as much electric load reduction as we can achieve before adding any potential new load, it has to be done. That really, and solar. So it's if until there is rate reform that is like successful and meaningful, there's no way you could do one without the other. And even then, you wouldn't want to do one without the other.
Even with the avoided gas bill costs, I mean, even that electric bill increase, it overrides those savings.
It not necessarily. It again depends on what the existing systems are. If there's existing air conditioning and you're putting in a heat pump, that's generally pretty safe. But if you're adding cooling, which in many cases they don't have cooling to begin with, and you're adding a whole new electric load by installing that heat pump,
your load's going way up, and there's just more gear, and your bill's going to go up concurrently.
But also, even if they have air conditioning, it's not necessarily going to go down because the cost of electricity is much higher on a BTU basis than the cost of gas. So
Yep.
until we can fix that through rate reform, it's always going to be a big issue.
And we know that's very much on the PUC's radar right now, especially as we go sort of NEM 3 or 4.0. And as Martha mentioned, vehicle to grid and looking at bidirectional charging and looking at how to go at that duck curve and all the new experimentation that CEC is taking on as part of the Strategic Reserve Administration. I think that's really one area I'm excited about for creativity and innovation, is looking at things like virtual power plants or ways to shave down the cost of that sort of big ticket resource adequacy that we do in big capital intensive work at the grid scale, and kind of realize some more of that value from our buildings. I know we're going to be wrapping up here shortly. Eddie says Eddie's going to cut our recording. So once he cuts the recording, then let's all say what we really think. No, I'm just kidding. You guys have been really candid. I really appreciate the tough and sort of honest look at things. But let me just give you a lightning round before you wrap up, see whoever wants to take it. Question about apartment size, heat pump water heaters, more modular, less space. It looks like Martha's going to tackle that one live, or give us a rapid fire on that, and then see who else wants to pick up.
I guess I will say we tried 2 different hot water heat pumps in the Veracruz project for this exact reason of space. And so I guess, obviously they're different. The Sandon had their compressor outside, so we were able to use a smaller closet space inside for that system, as opposed to the Ream where the compressor is on top of the hot water heater. But we have tried to work with manufacturers on changing their form factors, on developing combi systems where you could do heating, cooling, the energy recovery, ventilation, and domestic hot water, and kind of capture the efficiencies of all those systems. Andy has spent a lot of time thinking about this. He's happy to connect with you offline, but I will just say, manufacturers are slow to develop new products. So it has been sort of, from my experience, has been a very painstaking process.
Yeah.
But I do think these announcements, like the governor's, saying they're going to deploy 20 million heat pumps, hopefully that's going to get their attention. Hopefully DOE, changing the EPA changing their Energy Star requirements, for HVAC systems. I think all of these things are going to start really getting the attention of manufacturers, because now they're seeing the bigger market instead of some bespoke R&D projects.
Yep, I think that's right. And we really hope that this first big round of the Heat Pump Nation push post IRA and after the governor's goals is something that people like right away, and that you don't see the bill spike. But in fact, you're sort of doing that combined retrofit like we did during ERA, but it does take a lot of other pieces. And we know that, there's a lot of talk in the chat about generation and how it has to be paired. Andy, you mentioned that, but thoughts on, is generation sort of an on-site generation an indispensable piece of this? Can these projects pencil without getting some solar on site, whether it's at a multifamily for parking or driveways or single family? Like, does this necessitate a generation component too?
Yes.
Andy?
Multifamily, it's there's all sorts of challenges going, and you alluded to some of them with the switch to NEM 3 that we're going to be dealing with over the course of the next few years, figuring all of that out and how to continue to make solar effective and cost effective on multifamily affordable housing. But yeah, generation is definitely a huge piece of it. I mean, yes, California has a pretty clean grid, and it will eventually get to 100%. But until that time, we need to deal with it, and we need to set an example of what what it's going to look like nationally. And I think that's typically what California has done, is can move forward first, and then the rest of the country follows in many regards. And right now, and those other states, there are many states that are so far from having a clean grid that rooftop solar and on-site generation and distributed generation is going to be a critical piece.
Yep. And we know the future of net metering is sort of that combined solar storage too. So it'll be that combination of the generation, some storage on site, pulling some of that demand down, and then being a little less load averse than maybe as we install some of the new tech too. So it hopefully all that starts to go hand in hand, and the PUC goes and figures that out. We're at 2:01. We almost wrapped up on time, but you know, this is a high powered group, so I figured we could go over. I appreciate everyone. We got up to 80 participants in our breakout, so you guys are doing something right here. I think people are eager to learn about what the best in class research is all over the country, and I'm just grateful that the CEC is funding your work, and we want to keep that going in the California Legislature. So thanks for giving me a little taste of what happens when we're saying, okay, we got to keep the EPIC program going, and why. This is it. Anyway, thanks for being the why.
Yes.
Thank you so
Thanks
much.
very much. Happy Energy Efficiency Day.
Thank you.
Happy Energy Efficiency Day, guys.